Hello everyone, welcome to lesson 1-2, chapter 1, lesson 2, powers and exponents. For this lesson we will use words such as power, base, and exponent. Real world link, savings. Yogi decided to start saving money by putting a penny in his piggy bank, then doubling the amount he saves each week. Use the questions below to find how much money Yogi will save in 8 weeks. Complete the table below to find the amount Yogi saved each week and the total amount in his piggy bank. So we have the weekly savings, and the total savings, right? So we have each week on the top and the total, a running total along the bottom. So in the first week, okay, with 0 to 1 week, we have 1 cent. For the second week, that amount doubles, as saying here, then doubling the amount he saves each week. So if it's been doubled here, it will be doubled again, correct? And then doubled again. By the third week or second week here, we will have doubled it again to 4 cents, right? And then that doubles to 8 cents. And that doubles to 16 cents. And 16 plus 16 is 32 cents. And then 64 cents. And that's how it continues to double each week, making it a total savings of the sum of all these amounts. So we have 1 plus 2 is 3. 3 plus 4 is 7. Let's change that to red, 7 cents. And then we continue with 7 plus 8 is 15. 15 cents. 15 plus 16 is 31 cents. Okay, I can't fit the cent symbol in there. 31 plus 32 is 63 cents. And 63 plus 64 is $1.27. Right? $1.27. Question 2. How many 2's are multiplied to find his savings in week 4? Well, week 4 is right here, right? So we went from 1 times 2 times 2 times 2 times 2. I counted 4. 1, 2, 3, 4. Each time the number was multiplied by 2. So we have 4 right here. It was multiplied 4 times. The second part, by week 5, 5 times. Right? Just one more. 5 times. Question 3. How much money will Yogi save in week 8? Well, here we're at week 6, right? We need to go ahead and do it, multiply by 2 more times. So I multiply $1.27 times 2. Sorry, I said that wrong. 64 times 2. So, right, 64 times 2 would be $1.28. And then $1.28 times 2 would be $2.56, right? So $2.56 by week 8. Continue the table to find when he will have enough money to buy a pair of shoes for $80. Wow. Okay, if we continue the table at week 7, we said by doubling 64 up here. Remember, each week it gets doubled. Double 64, we get $1.28. Double $1.28, we get $2.56. We double that, we get $5.12. 512 times 2 is 1024. 1024 times 2 is $20.48. And when I double that, I get $40.96. And remember, we have to add all of these up. And we continue, it's a running tally. So if I add 127 plus 128, I get 255. I'll try to write smaller. 255. 255 plus 256. Remember, I'm adding it like this now. So now I have this amount, and I have to add the new amount from the following week. So 255 plus 256 is 511. Okay, 511. 511 plus 512 is 1023. 1023 plus 1024 is 2047. And 2047 plus 2048 is 4095. And 4095 plus 4096 is 8191, right? 8191, yeah. And there we go. So it would take 12 weeks, right? It would take 12 weeks. So what you just witnessed it was exponential growth, where a number continues to grow by the same exponent. Okay, so and that was a bit the exponent of 2, because it continued to double. So a product of repeated factors can be expressed as a power. That is, using an exponent and a base. Here we have 2 to the power of 4. 2 times 2 times 2 times 2. Our 2 is our base. And how many times that number is multiplied into itself is the exponent. So 2 is multiplied into itself 4 times. This is not 2 times 4. Please do not mistake in that. We have 2 multiplied into itself 4 times. So 2 times 2 is 4, times 2 is 8, times 2 is 16. Therefore, 2 to the power of 4 is 16, not 8. Do not multiply these two numbers together, because the exponent is not a number. It's simply telling you how many times this factor is multiplied into itself. Let's take a look at this table to see if we can find a pattern. 3 to the power of 1. Really, you don't have to write 1 because it's already just 3 in itself. It stands alone, right? There's only one of them. So 3 to the first power, it's just simply 3, right? 3 multiplied times nothing. 3 to the power of 2 means it's 3 times 3. Now the base is multiplying itself how many times? 2 times. 3 to the second power, or 3 squared, is 3 times 3. 3 to the third power, or 3 cubed, is 3 times 3 times 3. And 3 to the fourth power, okay, is 3 times 3 times 3 times 3. Let's see if we can do this quickly. 3 times 3 is 9, times 3 is 27, times 3 is 81. And that pattern continues. If you do 3 to the power of n, okay, so 3 to the nth to the nth or power, or 3 to the power of nth, we simply don't know how many we're multiplying it by, right? It's something we have to figure out, but it's 3 times 3 times 3 to the n factors, to the number of n. It's an unknown variable. Okay, examples. Write each expression using exponents. Please take a look at how this expression with the negative is written with exponents. So we have negative 2 times negative 2 times negative 2. How many times does it repeat itself? And then 3, positive 3. How many times is that factor repeated? Okay, and then we have to take into account that negative 2 to the power of 3, because there's 1, 2, 3, times 3 to the power of 4. And that's how we would write it exponentially. The same applies for unknown variables. We have one A over here and another A over here. So how many do we have? 2 of them, right? And how many B's do we have? 1, 2, 3. So we would write A to the power of 2 because we have 2 of them, you see. And we have 3 B's, so we have B. What we would use, though, is commutative property over here to make sure that we arrange them and we group them. Okay, if you think you got it, please pause the video and try A, B, C on your own, and then check your answer. Pause now. Okay, I hope you tried number 1 on your own. Number 1, we have a half times a half times a half times a half. How many times is this half repeated? 4 times, right? So we have the half to the power of 4. Now I put a parenthesis there because the entire thing is multiplied into itself 4 times. B. I see that we have 2 different bases here. We have a base of 4 and a base of 5. 4 to the third power times 5 to the square, or to the power of 2, right? And then for C, we have variables. We have m, and m here again. So I see that I have 3 of them, and then I have 2 n's, right? So I have m to the power of 3 times n to the power of 2. I hope you got these correct. Okay, example 3. Now they want you to evaluate. Essentially, they want you to give the real value or solve, okay? So you can see here that now we're being given the exponential format of negative 2/3 to the power of 4. You know that negative 2/3 is being multiplied into itself 4 times. It tells you right there. So 1, 2, 3, 4. Negative times a negative, positive. Positive times a negative, negative. Negative times a negative, positive. Notice that the exponent for a negative base is even. When the exponent is even, right, for a negative base, when the exponent is even, it's going to be a positive answer. If the negative base has an odd number, it's going to be a negative answer. Okay, if you did not get that, please rewind and listen to that again. And you can see that once you multiply 2 times 2 times 2 times 2, you get 16. 2 times 2 is 4, times 2 is 8, 8 times 2 is 16. And then 3 times 3 is 9, times 3 is 27, 27 times 3 is 81, so 16 over 21. Again, please, if you understand how to do this, pause the video now and try doing D, E, and F on your own. Pause now. Okay, D, what do we have? Well, for D we have 4 times 4 times 4 times 4, right? 4 to the power of 4, which would be 256. Let's try A, B, C, D, E. E, whoa, 6 times. Remember what I told you? If your base is negative and you have an even number, it's going to be a positive answer. If your base is negative but you have an odd exponent, it's going to be a negative answer. So let's try it. We have negative 2 times 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 negative 2. How many is that? 5? One more, times negative 2. So negative 2 to the power of 6 is going to be positive. And it's positive because my exponent is even. You see that? It's going to be positive 64. And finally, 1/5 to the power of 3. Right? To the power of 3 means to repeat itself 3 times. 1 times 1 times 1, numerators are multiplied, is going to equal 1. 5 times 5 is 25, times 5 is 125. I hope you got these correct, boys and girls. So how does exponent relate to real world examples? Well, let's take a look at example 4 and we'll figure it out. The deck of a skateboard has an area of about 2 to the 5th power times 7 square inches. What is the area of the skateboard? Well, 2 to the 5th power means 2 times 2 times 2 times 2 times 2. Or you can say 2 to the power of 5. You can say it either way. Times 7. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And then, so here, this value is 32. This is another way of writing the number, 32. So 32 times 7 equals 224. Okay, go ahead and give G a try. Pause the video now. I hope you tried it on your own. Here we go. A school basketball court has an area of 2 cubed, or 2 to the 3rd power, or 2 to the power of 3. You can say it all those ways. Times 3 times 5 square times 7 square feet. What is the area of the school basketball court? Let's write this in expanded notation. This is in exponential notation. Let's write it in expanded, which means we're actually going to write each factor. It should look something like this. 2 to the power of 3 is 2 times 2 times 2 times 3, right there, times 5 squared, 5 times 5, times 7. And there we go. 2 times 2 times 2 is 8, right? 2 times 2 is 4, times 2 is 8. 8 times 3 is 24. 24 times 5 is 120. 120 times 5 is, oh, I'm just doing here some mental math really fast, 600. And 600 times 7, 6 times 7 is 42. So it would be 4,200. That is my mental math. I hope I'm not wrong. Let me check my answer on the calculator. Okay, I just checked my calculator and now I was correct. I was not wrong. So what is the area of a school basketball court? The area of the school basketball court is 4,200 square feet. And as I've mentioned in the past, a word question needs to be answered with words. The area of the court is 4,200 square feet. Okay, now how does this apply to algebra? Let's solve for these algebraic equations here, or algebraic expressions, I should say. Evaluate each expression if a equals 3 and b equals 5. So you have a over here, which is 3, so it's 3 squared, plus 5, because it says here b is 5 to the 4th power, to the power of 4. You replace the variables, you write it in expanded notation, and then you solve. There we go. And the same applies here. You replace the variable with the same given values and you solve. Please pause and comb through these two examples to make sure that you understand, and read the steps as you go along. Now that you have an idea on how to do it, please pause the video and try these three on your own. H, I, and J. Pause now. Okay, answer H. We see that C is -4 and D equals 9. So here we have -4 and here we have 9, correct? So please replace the variables. And remember, when you have your base is a negative number and your power or exponent is an odd number, you're going to have a negative product, right? So -4 times -4 is positive 16. But then positive 16 times -4 equals -64 plus 81, because 9 times 9 is 81. And that equals 17. I. Okay, let's replace the variable as we see here, C and D. I have -4 plus 9 equals 5 cubed, right? To the power of 3, and 5 times 5 is 25, times 5 is 125. Let's try J again by replacing the variable. D is 9 and C is -4. So it would look like this when you replace the variable. You have 9 to the 3rd power minus, okay, the parentheses that we have here. I put into parentheses the -4 on its own, or nested parentheses, to the power of 2. So now let's solve using PEMDAS, order of operation. First I'm going to solve for my exponents, right? For PEMDAS actually is parentheses, so within the parentheses I have to solve for the exponent right here. And I get -4 times -4 is positive 16. 16 minus 2 is 14, right? And then over here I'm going to solve for 9 to the power of 3. 9 times 9 is 81, and 81 times 9 is 729. 729 minus 14 is 115. Okay, that looks like that's it for today. I hope you wrote down all those examples. Here is your guided practice for class. Please take a look through it. Make sure that you understand how to do it. If you do not know how to do it, I'm asking you to try to visualize it or do it mentally, or you find that it's a confusing question, go back to the examples that you see in the parentheses. Go back to the example on the video, and hopefully that will clarify things. All right, everybody, see you in class.